So today we're going to work on identifying a limiting reagent and an excess reagent. So we've got a reaction here where we've got 100 mils of 0.1 moles per litre copper sulphate being mixed with 50 mils of 0.4 moles per litre sodium hydroxide. And this is our balanced chemical equation: copper sulphate plus 2 sodium hydroxides gives copper hydroxide plus sodium sulphate. So the first thing we're going to do is calculate the mole ratio of our reactants that are mixed. Okay, our reactants mixed are our copper sulphate and our sodium hydroxide. So to start with, we need to calculate the number of moles of copper sulphate. Right. Okay, now we're given the volume and the concentration of copper sulphate. Concentration is 0.1. Volume is 100 mils, so 0.1 litres. Okay, moles equals concentration times volume. Times 0.1, which gives us 0.01 moles. Okay, that's for copper sulphate. For sodium hydroxide, we're given 50 mils at a concentration of 0.4. Same process, multiply them together. 0.4 multiplied by 0.05, because that's 50 mils in litres. Okay. 0.02 moles. Okay, so we've done step one. We've calculated the mole ratio of the reactants mixed. All right. So for this, it's 0.01 to 0.02, which is the same as 1 to 2 copper sulphate to sodium hydroxide. Okay, so we've calculated the mole ratio of our reactants mixed, 1 part copper sulphate to 2 parts sodium hydroxide. Our next job is to compare that mole ratio with our reacting mole ratio. Okay, so we use our chemical equation to work out our reacting mole ratio. So if we have a look here, copper sulphate, we've got 1 copper sulphate and we've got 2 sodium hydroxides. So our reacting mole ratio is actually the same as our mole ratio of reactants mixed. Okay, so in this case, if we're trying to identify the limiting reagent, we don't actually have a limiting reagent because all of the copper sulphate and all of the sodium hydroxide is going to be consumed in the reaction based on the fact that these two ratios are the same. So, as a general rule, we can say that when the mole ratio of reactants mixed equals the reacting mole ratio, there is no excess reagent. Okay, so if the mole ratio of reactants mixed equals the reacting mole ratio, then we have no excess reagent, then we don't need to continue on with step 3.